Okay, now let's look at example 3. Example 3, you are given a solid figure again. Okay, this time round it is a cone-shaped cup in an inverted position. Okay, so it's an inverted cone. And you're told that it has a height of 9 cm. And the radius, okay, of the opening of the cup is 3 cm as shown in the diagram here. And starting at t equals to 0, okay, orange juice is poured at a constant rate of 10 cm cubed per second. So this means that at t equals to 0, the cup is originally empty, and slowly, okay, you pour 10 cm cube of orange juice per second. So you find that, okay, the amount of orange juice will be increasing as time goes by. Now you're told that after t seconds, the level of orange juice in the cup is hcm. Okay, so express the volume V of the orange juice in terms of the cup of H. Okay, so let's look at this diagram here, assuming that, okay, this is the amount of orange juice that is poured in after t seconds. And you're told that is, okay, H, the height is hcm. Now, how would you find, okay, the volume of the orange juice? Now, you know that, you see, if you look over here at the diagram, the volume of the orange juice is in the shape of a cone, right? And we know that to find the volume of the cone, okay, you need the radius of the cone as well as the height. So what we have here is actually the height of the cone, but we don't have the radius. So before we find the volume, we need to find out what this radius is. Okay, is there a way for us to find the radius given, okay, what we have here? Well, we will need to make use of the concept of similar solids. So you can see that the cup here, okay, the volume here, the orange volume here, is actually similar to the bigger cone, right? So these are similar objects. And remember what we learned for similar objects is that the ratio of the size or the dimensions must also be the same for similar object. So we know that, okay, because of the similarity, we know that the ratio of the radius, okay, which in this case is r over 3, must be equals to the ratio of the height, which is h over 9. So we can express r actually in terms of h. So you actually get r is equals to h over 9 times 3, where, okay, you actually end up with h over 3. So we know that the radius r can be expressed in terms of h over 3. But the radius is not what we want to find. What we want to find is actually the volume. So if you recall, the volume of a cone is actually equals to 1/3 pi r squared times height. And in this case here, they want us to express the volume in terms of h only. So we will have to get rid of the r. And how do we get rid of the r? Earlier we know that r can be expressed as h over 3. So what we need to do is just to substitute r with h over 3. Okay, and we will be able to get the answer. Okay, if you work this out, alright, pi remains on top, h squared times h will give you h cubed over, I have here 3, and over here I have 3 square, so it's 3 times 3 square, which gives you 27. Okay, so you can express v in terms of pi h cubed over 27, and the units will be, remember, this is the rate of change of the, this is the volume. So volume is in cm cubed. Okay, so the first part here has nothing to do with rate of change. It's actually just expressing the volume in terms of the height h, and we make use of what we know about similar solids. Okay, then the next part, okay, rate of change starts to come in. We're told that at the instance when the volume is 8 pi, we're supposed to find the rate of change of the level of orange juice in the cup. That means that we want to find out what is the rate of change of the h here. Okay, so in B part 1, the aim of the question is actually to find out what is dH over dt. And using what we know about connected rates of change, we know that dH over dt can be expressed as dH over dV times dV over dt. Now, and dH over dV can be expressed as 1 over dV over dH, okay, times, and we are given in the question, what is dV over dt? Okay, look at the question here. We are told that orange juice is poured into the cup at a constant rate of 10 cm cubed per second. So we know that dV over dt is 10. So that leads us now to find dV over dH. Okay, how do we find dV over dH? We make use of what is found in part A. So we know that V is equals to, okay, pi over 27 times h cubed. Therefore, dV over dH can be found very easily, right? Because h is the only variable here. What we need to do is to bring down the power 3. Okay, pi over 27 is just another constant remains, and we reduce the power of h by 1. And you end up with, okay, this can be cancelled, and you end up with pi over 9h squared. Okay, so we can translate what we know over here. Remember, we want to find dH over dV. Alright, so that is as if though the dV and dV can cancel. So dH over dV is 1 over dV over dH. So we know that this is equals to 1 over pi h squared over 9. Okay, times 10. And we know that the reciprocal, what we can do is we can just inverse this. So we have 9 over pi h squared times 10. And you're told that you're supposed to find the rate of change when the volume is 8 pi. So now, the rate of change of the height here, we have it is given in terms of h. So we want to find this in terms of when the volume is 8 pi. So again, I have to do some working at the side. When V is equals to 8 pi, this means that, okay, pi over 27 of h cubed, okay, which we get from here. Remember, V is equals to pi over 27 h cubed is equals to 8 pi. Okay, then we can work out what h actually is. So over here, pi and pi can cancel because it's a constant. Alright, h cubed will be equals to 27 times 8, which is equals to 216. And if you find h, this will actually give you 6. So we know that when V is equals to 8 pi, h is equals to 6. And therefore, we can translate this back into what we found for dH over dt. Okay, so dH over dt is equals to 9 over pi h squared times 10. We can work this out. And you can get 9 over 36 pi, okay, times 10. Okay, let's work this out. This is 4. Okay, do cancellation again. This is 2. And you actually get 5 over 2 pi. And the units, remember, this is the rate of change of height. So it will be cm per second. Okay, so you can leave your answer as this, or you can work out what pi is. So this is the rate of change of the level of orange juice in the cup, which is h here. So we have found the answer, dH over dt is equals to 5 over 2 pi cm squared.